Welcome aboard this comprehensive guide to the Airbus A320 electrical system. Today we'll explore the intricacies of how this aircraft is powered from takeoff to landing. The A320 has 5 primary electrical sources: batteries, ground power unit GPU, auxiliary power unit APU, integrated drive generator IGG, and the Ramair Turbine RET. We'll also delve into the differences between DC and AC power and explain the role of the static converter in this sophisticated system. Let's start by turning on the batteries. The batteries supply to our plane initial power 28 volt. The batteries provide essential power for pre-flight checks and emergency situations. Now, let's connect the external power. This is done using the ground power unit, which supplies the aircraft with 115V 400 Hz alternate current power from the ground. With external power connected, we'll set the IROS to nav and turn on the fuel pumps, preparing the aircraft for APU startup. Next, we'll perform an APU fire test to ensure the system is functioning correctly. The APU not only provides electrical power but also supplies the aircraft with breathed air. This is crucial for starting the main engines and maintaining cabin pressure.
The APU generator is located in the behind of the aircraft.
Currently, both the auxiliary power unit and ground power unit are generating power, but the aircraft is using the GPU. We'll now disconnect the external power. The auxiliary power unit will automatically take over, supplying the aircraft with electrical power and bleed air. Next, we'll start engine 2. The IDG on engine 2 will now supply the aircraft with 115V 400 Hz power, as shown on the ECAM display. We'll repeat this process for engine 1. With both engines running, we'll turn off the auxiliary power unit bleed and shut down the auxiliary power unit. The edges on both engines are now solely supplying the aircraft's electrical power. Departing from runway 34 at Baku Airport. Now let's talk about the Ramair Turbine or RAT. This small turbine deploys from the fuselage in case of emergency to provide hydraulic and electrical power if the main engines and auxiliary power unit fail. I'll demonstrate how the RAT deploys and operates during emergency procedures. Here's the RAT, located outside the aircraft. It's a critical safety feature on the A320. Let's simulate an electrical emergency by turning off integrated drive generator 1 and 2 with the auxiliary power unit already off. The Ramair Turbine is now generating 115V 400 Hz power, ensuring our flight controls, hydraulics and avionics systems remain operational. In the context of aircraft electrical systems, understanding DC direct current, AC alternating current, and static inverters is crucial for grasping how power is managed and distributed on board Airbus aircraft. Direct current is a type of electrical current that flows consistently in one direction. In Airbus aircraft, DC power is primarily used for critical systems such as avionics, flight control systems, and emergency equipment. The DC power is supplied by engine-driven generators known as integrated drive generators (EGs) or by auxiliary power units (APUs). These systems provide stable and reliable power essential for flight control and navigation, ensuring continuous operation even in the event of an engine failure. Alternating current periodically versus direction, oscillating between positive and negative cycles. AC power is typically used for non-critical systems on Airbus aircraft, such as cabin lighting, entertainment systems, and galley equipment. AC power is generated by AC generators, which are also driven by the aircraft engines. The generated AC power is then distributed throughout the aircraft via transformers and distribution panels to ensure appropriate voltage levels for different systems. A static inverter is a device used to convert DC power into AC power. In Airbus aircraft, static inverters play a crucial role in supplying AC power to certain onboard systems that require it but do not have dedicated AC generators. These inverters are particularly important for providing AC power during critical phases of flight, or when additional AC power is needed beyond what the main generators can supply. Thank you for joining us on this detailed tour of the Airbus A320 electrical system. Safe travels and happy flying!